In this video, I'm going to try and explain how this plot right here was created using a thermistor, a blowtorch, and a cup of ice. So, let's begin. Here we can see the circuit that we'll be using for the lab. There are remnants from the previous labs in here, along with using the end scope just for troubleshooting at the beginning. There are potentiometers, that's a remnant from a different lab. The only part that I'm actually using for this lab is the capacitor and the resistor, which are in series, and the yellow line which reads the voltage across the capacitor and then is read by the Arduino, as you'll see later. This right here is the thermistor portion of the lab. That right there, that little thing that the camera won't focus on, that right there is the thermistor. I soldered it, these very thin wires, to this longer wire here, so that way I'd actually have the mobility to dip it in the water, which I'll be showing later. As you can see, it's connected to the input of my circuit right there, with those two leads which I also soldered on. Here we have the Arduino code that's used to produce the data that's then analyzed in processing and in MATLAB. Most of the information is in void loop right here. The first part of this function will create a square wave using one of the digital pins. The next part of it samples one of the analog pins that the capacitor, or later the thermistor, is connected to. This is then sent over serial, and that serial is then read up by the processing and saved by processing. This right here is the processing code for the capacitor part of the lab. What this will do is it reads in values right here, analyzes and does math on those values right here. It will then display those values, and I decided to choose to make lines instead of just plotting points. It makes the graph far smoother, as we'll see in just a moment. Then it also will save all of this data right here to a file which we can then analyze in MATLAB. Here we can see the processing code. I just started it and it has a 5-second delay at the beginning, and then it will begin, as you can see here. The blue represents the square wave that the digital pin is outputting from the Arduino, and the red represents the capacitor the voltage is being read off of the analog pin on the Arduino. We can see that it follows the characteristic capacitor charge and discharge cycles after 10 time constants after the change in state. That data that we just recorded is then saved in a file in the same folder as the processing code. We can then read this into MATLAB, as you'll see in just a moment. After the data has been saved to a file, we can then read it into MATLAB right here. The data is saved as a table, or as an array A. We then extract both of the channels, so the channel for the input function, which is in blue in my plot, and the channel that represents the voltage across the capacitor. We then plot this data to produce the graph, as you can see right here on the right. It looks almost identical to the plot that we just saw in processing. Some of the key notes are, again, this very steep slope at the beginning of the charging and at the beginning of the discharging of the capacitor. In addition, we can see that the red line looks exactly like a discharging and a charging of a capacitor, and the blue line is a very nice square wave. All of the plots up till now were using the 10 kilo ohm resistor with the capacitor. If we instead use the 100 kilo ohm resistor with the capacitor, we would see that our time constant, instead of being 2.5 seconds, would instead be 25 seconds, 10 times as long, which would mean the same plot would happen, except it would take 10 times as long, which would be beneficial because we would have a greater resolution in this region with a very high slope. That little dot right there is the thermistor. Here I have a glass of ice water, and of course, a blowtorch. So let's begin. So first, I'm just going to heat it up pretty far away. There we go. It's very hot now. I'm going to put the torch down and drop it in the ice water. Boom. Temperature is crashing right now until it gets down to about the freezing point of water. And that's that. So now let's look at what's on the processing software. What we're about to see is the exponential charging of a capacitor. But this is actually the thermistor. But they have the same plot because they both use an exponential function to describe their changes. So we just saw the thermistor heating up, and we're about to see it cooling down right now. There we go, it cools down. The shape of the curve of a capacitor charging is almost the same as the shape of the curve for the thermistor changing temperature. This is because of Newton's law of cooling, which also has an exponential function that describes the changes in temperature.